In this lesson, we're going to be going over complex numbers. So let's start with, say we were given an equation such as x squared plus 9 equal to 0. So just a basic quadratic equation, and if we tried to solve it, if we move the 9 over, then we'd end up with, we'd have x squared equal to negative 9. And then if we took, to solve just for x, if we took the square root of both sides, then we'd end up with x equal to plus or minus the square root of negative 9. But this is just not possible because the square of any real number is positive. It's never negative. If you took, I mean, 2 squared is 4, but if we took negative 2 and squared it, that's still 4. Or if we took negative 10 and squared it, that's still positive, and so on and so forth. So negative numbers don't have real square roots. So to make it possible to solve such equations, mathematicians, they invented an expanded number system, which they called the complex numbers. And it started with defining a new number, which they called the imaginary unit I. The imaginary unit I. And this is defined as, we have I equal to the square root of negative 1. And this is where I squared is equal to negative 1. So we have I squared, which will be equal to negative 1. And then if we square both sides, we have I equal to the square root of negative 1. So this is our first kind of big concept here that we have to know for complex numbers when we're dealing with I. The imaginary unit I. I squared is equal to negative 1, and I then is equal to the square root of negative 1. And so a complex number specifically is a number in the form a plus bi, where a and b are real numbers, and then I, as we just talked about, is the imaginary unit. All right, so this is our next big concept to remember. This is the standard form for a complex number. And a lot of times this is the form when we're solving complex numbers. That'll be the form that they'll want us to put the answer in. So again, we have a plus bi, right? That is itself a complex number. And then we can split it into two halves. So we have the first half, a, that is the real part of the complex number. And then b is the imaginary part, which, I mean, would make sense, of course, being as b is tied to the imaginary unit I. So just remember, a and b are real numbers. I is the imaginary unit. But then if we're asking the two specific halves of the complex number, a is the real part and b is the imaginary part, if we're splitting it into parts specifically. So just so we can see it with some actual, just to see it with some actual numbers, if we had, for example, 5 plus 7i. So the real part is the 5, and then the imaginary part is the 7. All right, just the 7, not the I. If we're just dividing it into parts, real and imaginary, 5 is the real part, 7 is the imaginary part. And I'm going to do one more. If we had 3/4 and we were subtracting 1/3 I, it doesn't matter that we're using fractions, still real numbers. That's all that matters. A and B are real numbers. So in this case, 3/4 is the real part. And then in this case, we'd have to account for, we're subtracting, so we'd have to account for the minus there. So the imaginary part would actually be negative 1/3 in this case. Negative 1/3 would be our imaginary part in this complex number example. And well, just in case you saw something like this, if we were just given 4i, so in this case, there's no a out front, which is fine. Doesn't have to be there. So in this case, the real part, our real part is just 0. Right, the a is not there, so there is no real part, so we would just say the real part is 0. And then the imaginary part would be the 4 in this case. All right, so just so you're able to see it with numbers in a few examples, seeing a complex number in the standard a plus bi form, and then distinguishing the real part from the imaginary part. Now, in order for two complex numbers, in order for them to be considered equal to each other, their real parts must be equal and their imaginary parts must be equal. So if we had two complex numbers, we'll call it a plus bi, and then our other one will have c plus di. So we have two complex numbers, and in order for them to be considered equal to each other, that can only happen if we'd have to have a equal to c, and then we'd have to have b equal to d. So they're equal if and only if the real parts are equal to each other, and then the imaginary parts are equal to each other. So as long as they meet this criteria, then we can consider two complex numbers to be considered equal. It's just something to keep note of. But now let's look at adding, subtracting, and multiplying complex numbers. And we're not going to worry just yet about division. We're going to focus on addition, subtraction, and multiplying first. So in short, when we're adding or subtracting the real parts, when we're adding or subtracting the real parts, adding or subtracting the imaginary parts, and then expressing the sum or difference as a complex number. So again, write out the standard form a plus bi. So all we're doing is we're taking the real parts, adding and subtracting, all right, the real part, and then the imaginary part, adding and subtracting, whichever we're doing, and then we're expressing that sum or difference as a complex number in the standard form. So let's just take a look at a couple examples. And for these, just like we'll normally see, let's make sure we write our answer in standard form for a complex number, a plus bi. So let's try do 9 plus 6i, and we'll be subtracting negative 4 plus 2i. So in this case, let's get rid of our parentheses. So we're going to have to distribute out that minus here. All right. So this will just stay 9 plus 6i. And then we're subtracting a negative 4. So if we subtract a negative, an easy way to remember, if you just think about it, the two lines coming together to form a plus sign. So we're subtracting a negative, which means we will be adding 4, and then minus a positive 2. So we got 4 here, and then minus a positive 2 will be minus 2, and then we still have the I there, of course. So we got it simplified down a little bit. At least parentheses are gone. 9 plus 6i plus 4 minus 2i. And then we have some like terms that we can combine here. Or if we think about what we were just talking about, if you want to still think about it like that, whichever, I mean, it's the same concept. We're combining like terms, or like we had been talking about, we're combining the real parts with the imaginary parts. So whichever way you want to think about it. So let's combine the 9 and the 4, our real parts. So we got 13, and then let's combine the imaginary parts, the terms that have the I. We have 6i minus 2i, so that'll be a positive 4i. So it looks like for this one we have 13 plus 4i. We are in our standard form, a plus bi. So this is going to be our answer for this first one. So now we'll do one. Let's do a addition one. Okay, let's do 5 plus 2 plus 12i, and we'll be adding to that negative 8 minus I. Okay, so let's start out by, just like we did before, let's simplify it down a tad. Let's get rid of all of our parentheses. So we'll have 5 plus, and then it'll just be 5 plus 2 plus 12i. And then we're adding a negative 8. So that would be the same thing as subtracting 8. And then adding a negative I, so we're just subtracting I then. 5 plus 2 plus 12i minus 8 minus I. And now we're combining our like terms. So we have 5, and we have 2, so we have 7, and then minus 8, so 7 minus 8 will put us at negative 1. And then we have, for our imaginary parts, we have 12i, and then we're subtracting I. So 12 minus 1 will put us at 11i. So we have -1 plus 11i. We are in standard form, so this is our answer for that one. So now let's take a peek at a multiplication one. And when we're multiplying complex numbers, we need to keep in the back of our head what we had discussed just a bit ago in regards to I, where we said that I squared is equal to -1. So that'll be something we'll have to keep in mind for doing multiplication here. So we're going to take, for our example, let's do 7 minus 4i, and we're going to be multiplying that by -8 plus 3i. All right, 7 minus 4i times -8 plus 3i. So we have two parts in parentheses here. So best thing for us to do is to FOIL this. First, outer, inner, last. So let's start with, so let's take the first terms. So we'll be taking 7 times -8. We'll write this out in case some of you, if you're not familiar with the FOIL method. So we're taking the first terms. So we have 7 times -8. All right, this is our F part, which is equal to -56. And then outer. So now the outer terms. So we're taking 7 and multiplying it times 3i. So 7 times 3i, which is equal to 21i. And then the I part, which is inner, so the inner terms. So we're taking -4i times -8. -4i times -8. And we're taking negative times negative, so we'll end up with a positive. So we have 32i. And then our L, which is the last terms. So we have -4i, and then taking that times the 3i, last term in each pair, in each set of parentheses. So -4i times 3i. That'll be equal to -12i, and then note that each term has an I, so I will be squared for this one. All right, so we FOILed the entire thing. So now let's put this together. So we have -56 plus 21i plus 32i minus 12i squared. All right, so we went from this up here, we FOILed it, and now we are here. So let's start with, we can combine these terms. These both have just a single I attached to them, so we can combine those. So we have -56, and then we have 21i plus 32i. So that'll put us at 53i. And then we have minus 12, and then here's where this comes into play. I squared, which we have right here attached to the 12, I squared is the same thing as negative 1. So let's replace that I squared with negative 1. Get rid of that then. Replace it with negative 1 according to our rules. So now that's gone. We can get that cleared out of there. So now we have negative 56 plus 53i. And then we have 12 times negative 1, which will give us a negative 12. So minus a negative 12. Remember, the minuses come together, they form the plus. So minus a negative 12 will become plus 12. And then now we have like terms here, the real parts, remember, call them that. The real parts, we can combine that. We have negative 56 plus 12, so that'll be negative 44, and then plus 53i. So we are in our standard form, a plus bi. So this all looks good here. This will be our answer, negative 44 plus 53i for that one. So again, big things for the multiplication, knowing how to FOIL, and then if you come out with an I squared, replacing that with negative 1, remembering that rule. All right, let's take a look at, now let's take a look at division of complex numbers. And for division, the key for us is going to be, call it the complex conjugate. All right, the complex conjugate, that's going to be key for us. And for a standard complex number, I should say, a plus bi, in that standard form, the complex conjugate of that is a minus bi. All right, so here we have a complex number, basic complex number form, and then here is its complex conjugate. So all we're doing is we're keeping the real part, the a, we're keeping the real part the same, but we're switching the sign of the imaginary part. So plus becomes minus, or minus would become plus. We switch the sign on the imaginary part. And how is this helpful? Well, when you multiply a complex number by its conjugate, it results in a real number because we remove the imaginary part. So just so you can see what I was just saying, so you can see that. See how that works here. If we had a plus bi, and then taken it times its complex conjugate, a minus bi, so if we FOIL that out, we end up with a squared minus, and we're taking a times bi, so we'll just have a bi, and then plus a bi, and then minus, we'd have b squared, because we're taking bi times bi, we'd have b squared, I squared. Okay, and now remember what we said, I squared, when we see that, according to our rule, that's equal to negative 1. So if we take the b squared times negative 1, then we come out with, this will be a negative b squared, and again, minus a negative, So this would end up as plus b squared. And mind you, these were minus abi plus bi, so these cancel out. So all we're left with is a squared plus b squared. And same thing if we went the other way and we had a minus bi and a plus bi, right? By taking a complex number, in this case, we're taking a minus bi, and we multiply it by its complex conjugate, switch the signs, a plus bi, it results in a real number, because this will come out to the same thing. It results in a real number, and we have removed the imaginary part. All right, we've gotten rid of, because this canceled out here, and then we applied the rule to get rid of the I squared, so we've removed the imaginary part, and all we're left with is a real number, because a and b in a complex number are the real numbers. So that's why we do the complex conjugate. And let's take a look at, well, here's the general, let me give you guys the general formula for it using letters so you can see it. So the general formula for you guys to remember, if we're dividing out complex numbers, let's say we were dividing out a plus bi and dividing it by the complex number c plus di. So we multiply both the numerator and the denominator by the complex conjugate of the denominator. So we're dividing out complex numbers, so we're going to use the complex conjugate. So we take the complex conjugate of the denominator, so we have c plus di. So the complex conjugate of that would be c, switch the sign, minus di. All right, that's our complex conjugate. And then we take that times both the top and the bottom, that same thing. That same complex conjugate gets taken times the numerator and the denominator. So this is just our general formula for dividing out complex numbers. But let's take a look at an example so we can see it more clearly. So we're going to divide, and then, like we have been doing, we're going to put the result in standard form. So let's do 9i, and we're going to divide that by 4 plus 6i. And remember, we're still dividing out complex numbers. Remember this part, we had that example earlier. In this part, the numerator here is still a complex number. Our real part is just 0. So we're still dividing complex numbers. So now, for dividing, so that means we need to use the complex conjugate. So we're going to take it times the complex conjugate of the denominator. So 4 plus 6i becomes 4 minus 6i. And same thing on the top as well. Okay. So we have it set up according to what we just wrote out, our general formula. So now, let's start with the top. So we're going to distribute the 9i times 4. So do some distribution here. So we'll have 36i. And then we're taking 9i times negative 6, which will be negative 54i squared. All right, because both terms have an I. So that'll be I squared. And now on the bottom, we're going to have to do some FOILing again. So start with the first terms. So we have 4 times 4, so that's 16. And then outer, so we have 4 times negative 6i, so that'll be negative 24i. And then inner, we have 6i times 4, so that'll be positive 24i. And then the last terms, we have 6i times negative 6i, so that'll be negative 36i squared. Okay. And like we saw before, when we were multiplying, we're able to get cancellation here. All right, negative 24 plus 24, that zeroes out. Okay. And then we'll be able to apply in the top and the bottom. 36i minus 54, and remember, we see that I squared. It's the same thing as negative 1. So we'll take that times negative 1. And then on the bottom, 16 minus 36 times negative 1. Okay? So we were able to get that cleared out, and then we're rewriting the I squared as a negative 1, so we're getting the I squared cleared out. So let's get this simplified down. So we have 36i, and then we have 54 times negative 1, so that's negative 54. So minus a negative 54 will become plus 54. Bottom, we have 16. 36 times negative 1, negative 36, minus a negative 36 will become plus 36. And then from there, we have 36i plus 54, and that is over. When we take 16 plus 36, we will get 52. We can take it, depending on what they're asking for, we'll take it a step further. We can split this fraction here, since our denominator is the same, so we can split this. So we have 52 on the bottom, we're adding, and then let's switch these around to put it in the standard form a plus bi. So I'm just going to switch around the order of the 36i and 54 in my answer. So 54 over 52 plus 36i over 52. Okay. And if we wanted to, we could take it one last step further if we wanted to simplify, because we could divide 54 and 52 by 2. So that would get us 27 over 26. And then on the right side, we could divide out, well, we could do 2, but then 20, because 52 divided by 2 is 26, but we could divide that by 2 again. So let's divide by 4. If we do 36 divided by 4, that gets us 9i, and then 52 divided by 4 would get us 13. And it looks like those are both simplified as far as we can go. So simplified, this will be our final answer. So 27 over 26 plus 9i over 13. And let's do, I think it'd be good to see one more division example. So for this one, let's do 3 minus 2i. And then that'll be over 5 minus 8i. All right, so we're dividing complex numbers once again. So times complex conjugate of the denominator, which would be 5, and now minus becomes plus 8i, and same thing on the top. Okay. And now in this case, we'll have to FOIL the top as well. So we'll have, if we start with the top, so the first term, so we have 5 times 3 is 15. And then the outer terms, we have 3 times 8i, so plus 24i. And then inner, we have negative 2i times 5, negative 10i. And then the last term is negative 2 times 8, negative 16i squared. And then when we FOIL the bottom, we'll end up with 5 times 5 is 25. And then the outer terms, 5 times 8i is 40i. And then inner, we'd have negative 40i. And then the last term's negative 8 times positive 8. We'd end up with negative 64i squared. All right, so do a little simplification here. So as we should have seen happen, because we were multiplying times the complex conjugate, so we have cancellation here, which of course we don't get on the top because this is not the complex, these are not complex conjugates. That's why we don't have elimination in the middle in the numerator here. So we'll have, so become 15, and then let's combine, we can combine these terms. We have 24 minus 10, so we'll have 14i minus 16i squared, and then on the bottom we're left with 25 minus 64i squared. Okay, so we got it simplified a little, and now let's take care of our squared equal to negative 1. So when we do that, we end up with, we have, so we're taking 16 times negative 1, so that'll be negative 16. So minus a negative 16 will become plus 16. And then on the bottom, we have 25, 64 times negative 1. So that's negative 64 minus a negative 64 plus 64. So if we simplify that down, let's combine the 15 and the 16. So we have 31 plus 14i is over 25 plus 64 will get us 89. So 31 plus 14i over 89, and then like we did before, if we wanted to take it one step further, we can break up the fraction. We have 89 on the bottom. We're adding. So we have 31, and then we have 14i And this time we didn't have to switch, we're already in standard form order, a plus bi. And these, neither of these will be able to simplify down any further. So it looks like this will be our final answer this time. So we have 31 over 89 plus 14i over 89. So now let's go back to the beginning of this lesson. All right, we had said when we were discussing the issue with square roots and negatives, because remember we were saying when we have x squared equal to negative 9, and then if we take the square root of both sides, we'd have x equal to plus minus the square root of negative 9. But as we know, we cannot take, this is not going to work for us. If we try, if you try to put that into your calculator, taking the square root of negative 9, you'll just get a big old error message. All right, so that does not work, but this is where our imaginary unit, I, comes into play. Because we've been used to using where we have I squared is equal to negative 1, but again, don't forget that that also means when we take the square root of each side, that also means that I has to be equal to the square root of negative 1. All right. So if we call this, if we use the variable, we'll use b for this. So if b is negative, then the principal square root, so this is kind of our next next rule that we're going over here, the principal square root. So if b is negative, then the principal square root of negative b is the square root of negative b equal to I times the square root of positive b. So that's where we're able to use, now we're able to use the imaginary number, use our principal square root, and we can say that if we see square root of negative b, again, we'll just call it, just using b as our variable, square root of negative b, we can change that to, we can make it a square root of a positive b. We just have to put the I out front, because obviously we can take the square root of a positive number. A negative we can't, but we can of a positive. We just have to put the I out front using the rule of the principal square root. So let's keep that in mind. That'll be another key to remember, because we've talked about, general form a plus bi of a complex number. We've talked about when we see I squared, we can set that equal to negative 1. Well, now we have another. If you see something like this, the square root of a negative number, that can be set equal to I square root of the positive number. So just to see that with some, instead of using b to see an actual number, if you saw square root of negative 16. All right, we can't do that, can't take the square root of a negative, but using the principal square root rule, we can change that to I square root of positive 16, which can be further simplified too, because we know the square root of 16 is 4, so that would just become, I4, but obviously we would put the I in the back, so equal to 4I. So square root of negative 16, we can simplify that down to 4I. Or if we had the square root of negative 3, all right, we can change that to I square root positive 3. And this one can't simplify any further. The square root of 3 doesn't come out to any nice even number, so we would just leave it like this in this case. So square root of negative 3 is equal to I square root of 3. So let's use that knowledge and let's apply it to an example here. So we're going to do 8 plus the square root of negative 20. And this is going to be over 30. All right. So we have that. As soon as we look at it, we can see, all right, we have the square root of a negative number. So let's use our rule, let's use our formula, and we know how to fix that. We can change that. So this can be changed to, we now have 8 plus, throw the I out front, square root, and then now we have positive 20 over 30. Okay? And let's simplify. I just want to do something with the square root of 20 itself. We can simplify that a little bit. If we were to take 20, that would be the same as 2 times 10. And then we could break that down into 2 times 5. And we can't break it down any further than that, the 5. So as soon as we have a common number here, so we can say that 20, this would become 2. The common number goes on the outside, and then whatever our last number is that we couldn't break down any further is what goes under the square root. So we have 2 square root of 5. All right. So we were just simplifying the square root of 20 is all. So square root of 20, if you were to put in your calculator, it'll come out to the exact same thing as 2 times the square root of 5. So I just wanted to break that down just a little bit in case they ask you to simplify it. So now we'll be at 8 plus, and now we're at 2 I, don't forget the I is still there, 2I times the square root of 5 over 30. Okay? And now from here, it looks like we could simplify this down a little bit. If we were to divide everything by 2, if we were to factor out a 2, divide everything out, we could simplify this down a little bit, and at least that would get us just an I out front. So if we divide 8 by 2, we'll have 4, and then plus, this would just become I, and we'd still have square root of 5, because we can't do anything with that. And then divide by 30 divided by 2 would get us 15. So we just divided everything by 2 just to simplify it down. And we were only able to do that because we could take it by the 8, by the 2, and by the 30. Again, we don't have to worry about the square root. That's under the square root. That's separate. We're not worried about that. But since we were able to divide these 3 terms by the same thing, we were able to simplify that down to something a little bit nicer at least. So we have 4 plus I times the square root of 5 all over 15. And then we could leave that as our answer or separate it again like we've been doing. So we'll have 15 on the bottom and 4 I square root of 5. And that will be our final answer, 4 over 15 plus I square root of 5 over 15. And let's do one last example. This one we'll still be applying when we have the negative under the square root, but just a slightly different example. So let's do -5 plus the square root of -144, and then this whole thing will be squared. All right, so let's start with, first things first, we see that negative under the square root, so let's apply our rule here. Okay, and if you forget, remember if we have square root of -b, that's equal to, we can put the I out front, and then this becomes positive. So this -144, square root of -144 will be equal to I square root of +144. And that we can work with, because what is the square root of 144? That would just be 12, and then switch those around, of course. So the square root of -144, we can make that set that equal to just 12i after we apply our rule and simplify it. So now, let's rewrite this. We have -5 plus 12i, and this is still squared. So now this is much more reasonable for us. So this will just look like, we'll have to do some foiling here. Be the same thing as just saying -5 plus 12i times -5 plus 12i. So if we FOIL that out, so we have -5 times -5, so we'll have 25. And then we'll have -5 times 12, so that'll get us -60i. And then we'd have inner 12i times -5, -60i, and then we have 12i times 12i, so that'll be 144i squared. And again, we won't have cancellation here because we weren't taking it times a complex conjugate, so we're going to have to combine our terms here in the middle. Okay, so careful with that. So we have -60 minus 60, so that'll be -120i plus 144, and then I squared. Same thing as we can replace that with -1. And then if we do the math on that, so we have 25 minus 120i, and then 144 times -1 will be -144. So plus a -144 will be minus 144. And then if we combine our like terms here, the real part, remember, we have 25 minus 144, which will get us -119, and then minus 120i. And that is our final answer for that one, -119 minus 120i. All right, so that does it for this lesson. Hope it was helpful, and thank you for watching. As always, be sure to check out the channel for more algebra lessons as they are posted.